Better Buildings for Humans is powered by Advanced Glazings, makers of the Solera line of products. Solera is the leading glass glazing made specifically for architectural daylighting and with extreme insulation performance. Learn more at advancedglazings.com. Hello, and welcome to this week's episode of Better Buildings for Humans. This is the podcast where we talk about the impact that the built environment has on we humans and how it affects our health, our wellness, our productivity, and our just general joy of being alive. And of course, we always talk about sustainable design as well. I'm your host, Joe Menchefski, and today I have Liz McCormick. She's a prof at UNC Charlotte. I usually don't do an intro, but I'm going to do a little intro today because it's just so cool. I'm going to read the first line of her bio at her UNCC website. It says, Assistant Professor of Architecture. Liz McCormick is a licensed architect, educator, and researcher whose work explores healthy, climatically sensitive, and contextually appropriate building design strategies that connect occupants to the outdoors while also reducing the dependence on mechanical conditioning technologies. And I read that because Dr. McCormick is absolutely speaking my language, and I'm so excited to have this conversation today. Liz, welcome to the show.
Thank you. Thank you so much for having me.
Oh, it's a pleasure. Look, let's start by having you tell your story, how you came to be a professor of architecture, how you came to choose UNCC, and your areas of interest and research.
So it all started really, I did a bachelor's of architecture. I did the 5-year program. I had no intention of going back to school, and I went straight into practice. I got licensed. It was 2009, so there weren't a lot of jobs. Moved to New Mexico, then moved to Seattle, and then ended up in Houston working for a large corporate firm that focuses on sustainability. I was really wanting to be focused more on sustainability. And I was put on the design team. And I was working on this project. It was my first big project that I was doing on my own. And I had just completed Passive House training. So I ran an energy model. I ran the project through the PHPP. And I showed it to the design principal. And I said, look, here's what I've designed. Here's the energy performance associated with that. He said, that's not your job. You're just the designer. We have a sustainability team to do that analysis work, but you'll do the design and then they'll do the analysis. And I thought, okay, well, how is that going to work? They're based out of San Francisco. I'm in Houston. And I think it was at that point where I decided, okay, I don't quite have the skills I need to be both. And I probably need to go back to school. So that's when, after 7 years in practice, went back to do the Master's of Science. And I wanted it to be my job. I wanted to do both design and sustainability because I didn't think that they should be separate. So that's basically how I got back to school. After that, I went to a firm in New Orleans, did research in practice, and then went into teaching. And it's been a happy little environment for me. At UNC Charlotte, we have a large cohort of building science researchers doing all sorts of different things. And it's been great to be part of that because a lot of schools you go to have, you're the expert in sustainability, and that they always invite you to the reviews and then so that you can give the sustainability feedback. But at UNC Charlotte, we actually have a whole team of people who it's our job now, to all circle back to that not your job moment.
Right. Did you get to work with Blaine Brownell at all?
Well, he's my boss. I've got to.
Oh, okay. Yeah, he's an amazing person. That'd be a really cool guy to have as a boss.
Yeah.
All right. I want to go straight to your book. It's called Inside Out: Human Health and the Air Conditioning Era. Now, the book talks about the condition indoors, and I assume you're making the case for more connectivity in the natural world. Is that correct?
Yeah.
Why is that connection important? Let's start there.
I think the question is really, why are we so disconnected in the first place?
Okay.
We are natural beings. Why do we create environments that completely isolate us from nature? The book is not about strategies. You do this to be more sustainable, to be more healthy, to be better connected. It's really to introduce people to the context behind why we've made the decisions that we've made in the built environment so that we can choose to break from that. Buildings were designed, the modern buildings, the airtight buildings that we typically have, they're not designed with human health in mind. They're designed to make machines run effectively so that machines can cool us and warm us So buildings are really designed for machines, not humans. And so what the book is about is trying to say, okay, let's not keep tinkering with buildings, make them more efficient, make them healthier. Let's step back, understand where we diverted from where we needed to be going, and go back to that point and rethink the paradigm of the sealed built environment. It's not good for the human body. The human body needs diversity psychologically, physiologically. We need that, you know, diverse experience, whether it's with sensation or temperature, microbiome, all of these different things that are actually good for us. We've engineered out of the built environment.
Okay, so it's more about the book is more about the making the case in the first place for reconnecting. Can we talk about strategies?
Strategy. So, what do you want to talk about?
I want to talk about, we've established that humans should not be truly isolated, like fully isolated from the natural world. I mean, there has to be some degree of separation and protection from extremes, but we shouldn't be fully isolated. How do we change our paradigm on how we design buildings in order to rebuild those connections that are so important?
The first thing I always say to do is to do an audit of yourself. How much time do you actually spend indoors? Because you have that EPA statistic from I think like 1987 or something. Americans spend 90% of their lives indoors, not including time spent in cars or in transportation, that sort of thing, which brings it up to 94, 95%. That seems like a crazy number until you actually sit down and do the audit. I did that a few years ago when I was just starting to think about these things. And I was at like 98% time indoors. And I was commuting by bike. I was making effort to spend more time outdoors, but you spend a lot of time in there. So the first thing to do is just to understand where you are in that statistic. And the other thing I always say to do is monitor your air quality. I bought an air quality monitor a few years ago, and it's completely changed my practices at home. I open my patio door a lot more. Sometimes the air quality is good and I don't need to, but just understanding the metrics associated with my behavior, it's been really transformative.
Okay. Let's talk about the future a little bit. Where do you think, building technology will be in 10 years, 20 years, 50 years as we try to rewind a little bit technologically and connect ourselves more to the natural world? How do we do it through buildings as well as lifestyle?
Yeah, I think, when you talk about connecting with nature, there's a habit of saying we should reconnect or that, there's a nostalgic sensation associated with it. There's a lot of benefit in the technology we've developed. Our buildings are tremendously better than they were 20 years ago. So there's a lot that we've done that's really good. And it's not necessarily to say we need to go back to a time where things were better. I think we can take the things that we've learned. The point was that I was getting to is that it's not a nostalgic way to talk about architecture. It's a forward thinking way that we don't just separate, this is the engineer's job, this is the architect's, this is our interior designer, that sort of thing. Is that engineers and architects work a lot more closely hand in hand to develop technologies that are human centered as opposed to focused on the machines. And even, throw an ecologist in there, a biologist, there's no reason we shouldn't be talking about microbiome when it comes to buildings. And that's, we are a lot more. And there's a chapter in the book about that. But to introduce that level of diversity is not just one trade that needs to do that. It's multiple disciplines that need to be working together on that front.
Okay, can you tell me a little bit about what those multiple disciplines would be doing in order to move forward into a new connected era?
So I'll answer that based on the four chapters of the book from my four contributors because I had Sarah Haynes, I always get this wrong because she does like four different sciences: ecology, biology. She teaches in the Department of Mineral Science at the University of Toronto, but she focuses on the indoor microbiome. Then there was Marcel Harmon, who I know you've spoken with.
Yeah.
He's an anthropologist and the research lead at an engineering building science company. Z. Smith, who's a practicing architect, director of building performance in New Orleans, and Ulysses Sean Vance, who's a practicing architect, academic, but his research focuses very much on health equity. And so his chapter is called Respiratory Equity, making sure that all people have access to clean and healthy spaces. And so I think with Sarah and Marcel, especially, they brought a new side to a new arguments to this conversation where thinking about the microbiome and not just taking the antibiotic approach but more the probiotic approach where you're introducing we're not introducing you're allowing different bacteria to thrive in these environments because they're good for us. Marcel brought the component talking about human behavior and how we react to different changes, and I think from an anthropological standpoint, he's a really important voice, or that field is really important to have because, again, these buildings are for humans. Humans are going to be living in them, they're going to be reacting to them. And so when it comes to complexity of a building, I'm kind of anti complexity. It should be as simple as possible so that humans are able to use them. And that's actually something I learned from Z Smith. He always used to say, oh, what was it? Smart buildings need dumb people, need smart buildings, or dumb buildings. I messed it up. I ruined the punchline. But the idea is that to be in a smart building, you have to be complacent. You just have to sit back and let the building do its thing. To have a simple building, you need smart people who know how to open the window when it's time to open the window, or those sort of things. It has to be managed in a deliberate way where you're not just sitting back letting the building do its thing.
Does he include automation in that approach?
I'm sorry, say that again. Does he include automation?
Yeah, is that or is it really that he wants the humans to be actively involved in managing the building?
I think automation goes into the category of a smart building where somebody is behind the scenes saying, okay, when it gets to 70 degrees outside, then the window opens. And that the occupant is still just passive. They sit there and they receive the benefits of that automation.
Okay. Okay. All right. I want to talk, let's change gears a little bit. I want to talk about your work in climate resistant architecture. Can you first define what that means and then maybe tell us the kind of work that you're doing to move the field forward?
So there are two ways that I'm looking at that. The first is in two different environments. I'm working on a project with a large architecture firm that's based across the U.S., but I'm studying four of their offices in the U.S. Southeast, understanding how often people use their outdoor terraces in the workplace. So it seems like a fairly simple study, but what it's actually trying to do is merge that information with historical anthropological data to understand the human nature relationship in the workplace, because that's very different than just the human nature relationship in general. So that's the first thing of just understanding why we do the things we do in the workplace and how real estate companies or designers can start to integrate those in urban environments in a more meaningful way. The other thing, which I just returned from Tanzania, I'm running a NSF funded research study there with a group of students that we just brought. And we're looking at malaria-resistant housing. And so what this is looking at, I mean, there are a ton of people doing that kind of work. At a large scale, you bring in bed nets, you bring in insecticides, those sorts of things to reduce bites from mosquitoes that carry disease. But it's a very top-down approach. It doesn't fit into all communities. And what we're trying to do is actually work the exact opposite direction. We're working with the brick, the most accessible of building materials, to create alternatives to traditional earth and bricks that allow air to pass for thermal comfort, reduce transmission of mosquitoes into the home, and also make it really accessible and easy to add. The community accepts it willingly. The community is developing it with us. So that's really the approach that I'm looking to take with climate resiliency, is that you're not developing something. I don't have something special to add. That's why I'm always resistant to talk about strategies, but it's about developing the teams and learning from people who are in the communities doing the work already and collaborating with them. So it's a very bottom up approach.
So the wall materials, the building envelope that you're talking about, is this, will it be materials that are available locally and can be easily manufactured or created locally?
Yeah, so what we're actually looking to do is develop the mold that would be moved from site to site or could be built on site. Because in a lot of the different areas, they dig the mud for the bricks from the site that they're building on. So it couldn't be more local than that. So we're not looking to change that process at all. We're just looking to maybe change the form or change some of the processes, but it wouldn't be a huge disruption to the construction industry there.
Okay, so it's the same material. It's just a different, literally a different physical shape, different form.
Physical shape, but we're also looking at, we've been working with the lab and the University of Dar es Salaam because there's a big trend in putting cement into the earthen blocks. But in the community we're working in, there's not a lot of access to cement. And also, when they do have access to it, it tends to, it's the emissions from the cement burning process are really high. So what we're actually looking at is non-industrial binders like starch, cassava flour, those sorts of things that can improve the strength of the block without the heavy emissions from the cement. So it's working at multiple scales with the lab, the community, and the entomology team, actually testing how many people are getting bit as we're integrating these things into the homes.
All right, that's amazing. Okay, I want to change. I want to change tack again. Usually when I'm talking with professors, it's all about research, but I want to talk about teaching a little bit. I can already tell in our conversation how much you love working with students. Now, you created a course called High Performance Low Tech. First of all, tell us why you thought that program was necessary and what the students will learn in that program.
So, in architecture, in academia, there's a big trend towards high tech solutions, simulations, and energy efficiency optimization, that sort of thing, which I will say, going to grad school at MIT, coming from RISD, which was an art school, I didn't really know what I was doing when I got there. And I thought, okay, well, maybe it's just not the way my brain works. I'm not good at these things. But I actually had something to contribute because I had that really strong design background. And so it's the idea that it's a low tech approach, that you're not starting with adding solar panels or adding a high tech facade, that you're just understanding how heat moves. And so what this course is, it's they come up with a building science problem and they develop a way to test it and visualize that problem in very simple ways. So a lot of people look at desiccants, or I've had a number of students look at desiccants. So they build a little box, blow steam through it, and then they understand how the different materials absorb moisture. So it's just a very simple approach, but students don't typically work this way. They go straight to the computer, they go straight to, Palette 2030 and pick the most high tech approaches and apply it to their buildings. It's not integrated. But when you're talking about, convection, conduction, radiation, just the three very basic modes of heat transfer, then they're able to understand the building in a much more thoughtful way. And so that's what the course is based on. But it's also, this is something that I've taught for a number of years. It was, it's had different names. Build Test is the original name. Buildtest.com is the course website with all the student projects. But what I did to the course when I submitted it for the ACSA prize is add the concept of vernacular architecture into the beginning part of the project. So they would study traditional modes of architecture, understand the basic building physics of what's happening, and then think of ways that they can innovate on that concept using the same principles, but also embracing what we know now. So the course has attracted a lot of international students looking to do studies on, some of the communities that they came from, or, vernacular architecture in their home countries, and then studying that in the concept of, or in the realm of building physics. And this, I mean, building science is not typically the most popular course in architecture education, but it was a really fun one because we did electronics, we did, we blew smoke through different things, we, did ink baths, and it was just a very visual way to learn about physics, which is the foundation of all the things we do in architecture.
Yeah, that's really cool. You won an award for that program, right?
Yes.
Was it a Buell Center Course Development Prize? What's that prize meant to celebrate?
It's, I don't know it has, I think, three or four winners a year, and it's just for course innovation and leadership and teaching. I'm not entirely sure. They have a really nice blurb about what it is, but you get a small cash prize. And, it's funny because for this class, the whole thing is low tech, low cost. I give each of the students $50 a year to do their entire experiment, build their sensors, build all their electronics, all their materials. And that's it. So after a couple of years of teaching the course, I still had money left over because the entire concept is to not spend money.
Right. Yeah, that's brilliant. Yeah, I love that. And congratulations. Yeah, that's a wonderful achievement. All right, let's talk about a paper. Some of your papers have the best names, the absolute best titles. You released a paper in 2023 called "Democratized Innovation and Accessible Thermal Testing: The Approachable Hot Box." What is the approachable hot box, and how does it democratize innovation?
This came from, again, being a student at MIT and not knowing what I was doing, and everybody around me was doing really advanced stuff. And I built a wooden and foam box, and I said, okay, I'm going to start testing samples between this. And everybody said, no, you need uh, energy meter and heat flux meter and all these different things. It's going to cost you thousands of dollars. And I was like, yeah, I don't know. I'm just going to do it and see what happens. And so I built this thing, and the entire premise of it is, it's everything I've been saying. It's making building science research and innovation accessible to people without advanced computational skills, or even without computers, or people who just have an idea and they want to test it in a rigorous way, but in a way that's not complex. So the idea of democratized innovation is that here's this thing that we built as a team to do very simple things. These are the things you can also do with that. So it's not to say that innovation only comes from academia, from high tech labs. It's that people in communities can do very advanced, sophisticated things with not a lot of resources. So that's the idea of the democratized innovation concept.
Love it. I love that. Okay, I want to talk about another paper with an amazingly cool
Another
title.
weird one.
Another, just an amazingly cool title that I love as well. Okay, so this one's also from 2023, and the title was "Process Oriented Design Methodologies Inspired by Tropical Plants." How can tropical plants inspire a design methodology?
Okay, so tropical plants are the coolest thing ever because plants that exist in uh, extreme environments, particularly like cacti or succulents, they have a specific adaptation to make them use resources more effectively so that they can survive in these extreme environments. Grasses are another field subject, or I don't know, the biologist I work with is going to get mad at me for messing this up, but they're another area of where this specific metabolic pathway is used, where it's just a very efficient way of doing things. And so when people are looking to genetically modify crops, they're trying to adapt this specific pathway into their crop to make it more efficient. And so when you look at these plants and you look at buildings and you think, okay, buildings are pretty static. You build them, they do their thing, and then you tear them down, 50 years later if you're lucky. But what these plants do is that it's essentially the skin of the plant will change based on the conditions. And so what we were trying to do was develop blocks, building envelope things to adapt to changing conditions. So if it's more humid outside, it will, depending on what the building needs, it will either open up or block the humidity. Or if it's hotter, depending. So it's a dynamic facade system without using actuators or various different things. So we're looking at materials like wood or cottons, or natural materials that actually respond to changes in temperature and humidity. So wood will warp if it gets humid. That can be used in facade settings. So the paper, again, you'll notice the trend here, is not about strategies and solutions, but it's actually about how studying these tropical plants can actually impact the design process. So that it's not just about applying materials in the end. It's about understanding the materials at the biological scale and responding in the same way that the plants would. So it's about that's why it's called process oriented. We don't necessarily have a test case, but it's about changing the way we think about design and innovation using these plants as an inspiration.
You're changing the way we experiment and learn.
Yes.
Oh, I like that a lot. Can you give me another example? I love the idea of the wood absorbing the moisture, warping, and that probably creates an opening or something. I would assume. Do you have any other examples? I love hearing these examples.
So what we actually did in the paper was that we used ice as formwork, so that the as the and the wax was our product that we were pouring. So as the wax melted the ice, it would evolve the way that the form was shaped, so that we couldn't actually design the formwork or the end product. The end product came from the way these two materials reacted together, so that it kind of gave design authorship to the formwork and the ice and the wax. And it took some of the authorship out of our hands because we didn't have a lot of control. We could guide the process a little bit, but it really came down to the synergies of these two materials.
And what would be the end goal there? What would you do with the wax form once it's been created?
Yeah, I think ultimately what we'd like to do is to have other poured materials like plaster or concrete and have a formwork that's similarly dynamic so that what we were looking at was have something become gradually more permeable as it gets deeper into the material, that sort of
Ah,
thing.
oh, okay, okay. And still maintain structural integrity,
Mhm.
compressive strength and all. Okay, that's really interesting. All right. So let's ask the $1 million question. Every show, Liz, every single episode, I ask people this question, and I ask them to answer it from whatever perspective they would like to answer it from. Okay. And the question is, what makes a great building?
What makes a great building?
Yeah,
I saw that on the list of questions you sent, and I was like, oh, I'll think of that on the spot. No big deal, easy question. But that's actually a really hard question
it
because there's
is.
so much to it. So I would say what makes a great building is a building that's designed for humans. And the way that we're building is not currently designed for humans, it's built for machines. And also, when I first saw this question, I thought, okay, well, maybe it's not the word building, it's our what makes a great environment. Because I think part of the problem with building is that it is this isolated box that's separated from the environment, that sort of thing. But if it's a building or an environment or an ecosystem, then I think that it changes the way we talk about architecture and the way we inhabit the built environment.
All right, let's finish with this next question. What else are you working on, Liz? What exciting things have you got on your agenda right now that the world needs to know about?
Yeah, so we just got back from Tanzania. This project that I mentioned, entomologicalhappenings.org is our website that we're currently building. But this is the first year of a 3-year project, and we just received additional funding for it. So I think there's a lot of cool stuff that's going to come out of that project. It's really in its infancy. We're developing research partnerships. And you called me Dr. McCormick in the beginning. I'm like weeks away from finishing my dissertation. So not
Oh,
officially a doctor, but that's in process as well. And I have a couple of papers that are going to be coming out of that, looking at the buildings in the Southeast, looking at the use of the outdoor terraces. So I'm really excited where that's going to come from, what that's going to turn into. It really builds off of the book and hoping to turn that into another book, really more about the outcome and the theory that was developed from that project.
will you come back on the show when you're farther down or close to the
Oh,
end?
Joe, I'll come back next week if you'll have me.
Oh, absolutely. Yeah, I really want to have you back and talk about the progress on this project. This is a really interesting and potentially really important project. So, yeah, let's talk again when this gets a little closer to the end. Anything else? Well, you just announced that you're only weeks away from your PhD, which is a great. Is there anything else that you'd like to announce, Liz?
I don't think so. I mean, it's the
Okay.
first week of school. I'm just trying to catch up.
Right. Yeah. Look, it's been an absolute pleasure speaking with you, Liz. It was a joy chatting with you. Thanks so much for being on the show.
Thank you.
Of course. Take care.
You too.
We hope you enjoyed this episode of Better Buildings for Humans. For more information on the world's best light diffusing and highly insulating glass glazing, please visit advancedglazings.com.